Hello everyone, welcome to today's math class. Today we have this algebraic equation before us here. The question is x to the power of 3 equal to 5 to the power of 3. What are the three rules to this challenge? Okay, so we take a solution here. So we move this quantity to this side of the equation. This will give us x to the power of 3, then minus 5 to the power of 3. This is equal to 0. What we see here is just simply difference of two cubes, right? So what does it say? It says that if you have your a to the power of 3 minus b to the power of 3, this is equal to your a minus b close bracket, then bracket your a squared plus your ab plus your b squared close bracket. All right. So with this difference of two cubes, we can rewrite the left-hand side of this equation. So this is going to give us here our x then minus 5 close bracket, then bracket open our x to the power of 2, then plus our 5x, then plus our 5 to the power of 2 close bracket equal to 0. So here we have two case scenario here. We equate this to 0, we equate this to 0. So we take our case 1 is going to give us something nice. So we have x minus 5 is equal to 0. So we have our x1 is equal to 5. Okay, this is the first solution to the equation here. So we check our case 2 because we have to look for three roots. The power of this variable here suggests the number of roots we solve for, which is 3 here. So how do we get the other two roots? So we take our case 2. So considering our case 2, we now have our question is x to the power of 2 plus 5x plus 5 to the power of 2 equal to 0. 5 to the power of 2 is 25. So rewriting this, we have x to the power of 2 plus 5x plus 25 is equal to 0. This is a quadratic equation. So we have to solve this quadratically, right? Good. So solving this quadratically, we want to use the formula method in solving this. So using the formula method, formula method, okay, so we know that our x will now be equal to minus b plus minus the square root of our b squared minus 4ac all over 2a, right? Good. What is our a? Our a is equal to 1, b is equal to positive 5, and c is equal to 25. So let's substitute in. So this now implies that our x is equal to minus 5 plus minus the square root of our 5 here, all to the power of 2 minus 4 times 1 times 25, right? Everything all over 2 times 1. So this will now give us minus 5 plus minus square root. Here we have 25. 4 times 1 times 25 will give us 100. So we have minus 100 all over 2. So again, we can solve for the quantities inside this radical. So this will give us here minus 5 plus minus square root 25 minus our 100 will give us 75. 75 all over 2. Now 75 is not a perfect square, but 75 can be written as 3 times 25, where 25 is a perfect square. So we can rewrite what we have inside the radical. So we have here minus 5 plus minus the square root of 25 times 3 all over 2. Okay, so let's continue on this side here. Rule of this, and it down here. All right, so we now have our x will now be equal to, here we said this is 25, which is a perfect square. So this is going to give us 5 times root 3. So we're going to have this to be minus our 5, then plus minus 5 into the square root of 3, everything all over 2. Okay, so we have two solutions to this expression here now, right? So what are the other two solutions from here now? We can now say here our x1 is equal to 5, our x2 is equal to, here we have the minus 5 plus 5 root 3 all over 2. And our x3 is equal to minus 5 root 3 all over 2. Okay, so these are the three roots to this wonderful algebraic equation. All right, now I wanted to do a check on these three roots. But again, if you want me to do a simple check on these three roots, drop it in the comment section. And I'm going to make a video that we actually give a thorough check to these three roots, which is the first one being a real root, then this one being a fractional root with radical, then also this one with this radical. I'm going to do a check for this root. I've done that on my own already, and they both satisfy the original equation. Okay, but all right, again, let's do a simple check for the first one. So let's take a check for the first one. Check. We have here, our question is x to the power of 3 equal to 5 to the power of 3. So want to confirm the first one, which is 5. So we're going to have here 5 to the power of 3 is equal to 5 to the power of 3. And what is 5 to the power of 3? We have 1, 2, 5 equal to 1, 2, 5. So this shows that the first one satisfies the original equation. Okay, so this first one satisfies the original equation. But take a look at the second one and the third one. Will these two satisfy the original equation? Oh, I don't. Yes, this and this will definitely satisfy the original equation and work on that, and it does satisfy the original equation. So if you want me to make a video on how to check for this second and the third rule, if they satisfy the original equation, leave it in the comment section below and I will reply to you. And again, I will make a video swiftly on how to verify these roots in the original equation. Okay, so this brings us to the end of this math class. If you've learned something from this video tutorial, then give the video a thumbs up. And if you don't subscribe to our channel, then do it to subscribe, because at Math Prowess, we drop videos all the time for your learning, for your fun. Thanks for watching Math Prowess. We meet you in our next class. Bye for now.